Okay, this is the third video about question 3. Question 3 is a little variation of homework question. So, and let me show you the answer. So it is it has a clear motivation from economics using Cobb-Douglas production function with constant returns to scale. So far you have to be familiar with what's going on, and you have in the end this regression equation. So I'm going to call this structural form equation. So this is what the economic theory implies. But uh, so this is not convenient to implement. There are two different ways to handle this. First one is to treat these two variables as a separate variables and just assume gamma is another parameter for k. However, it satisfies this relationship. So beta plus gamma equal to 1. We know them by the constant returns to scale assumption. And when you minimize the least squares estimator criterion function, then you use this constraint like Lagrangian method. So Ahmad did it. No, not Ahmad here. Karan did it. Did using Lagrangian method. It's not wrong, but the problem is actually I did not intend this way. Lagrangian method, you learned it in microeconomics. That is right. But the problem is what you learned is just how to use it. Just a very superficial result of the Lagrangian method. It's totally different to prove how Lagrangian minimization works. So in this case, I am asking you to prove it is the unique minimization of that problem. Then it requires much more work to prove that in the Lagrangian programming setup. So I took a class about that in the past, so it requires a totally different theory, programming and optimization. So it usually, when I took this course, I took this at Yale when I was a PhD student. Usually a month is spent on the proof of Lagrangian programming. I forgot everything, but it is not the same as what you learned. So what you learn is just the conclusion, but uniqueness is not simple, and at least you have to use the bordered Hessian matrix. If you do not understand what is bordered Hessian, then your proof is not complete. So the second order condition, especially the second order condition, is more complicated, and the idea is let me explain briefly. Just you don't need to understand this. So in this Lagrangian setup, criterion function includes this constraint, Lagrangian multiplier lambda, and constraint equation. This is right, idea is right, approach is right, but you have to include lambda as a new parameter. It becomes, so the function, criterion function, is a function of parameter beta and lambda. The restriction matrix R and C are known, so they are not an argument, but lambda is an argument. Then you are looking for minimum point for beta. You are looking for beta that minimizes that function, but at the same time, on the other side, lambda is a parameter, then lambda is the maximum of that function. So you may think it's weird. We call this saddle point. So it's like say beta is one dimensional and lambda is another dimension. Then from beta dimension it is minimum. If you consider cross section across across beta, then it is minimization. But if you cut it orthogonally, on the axis of lambda, it's a maximum. So it is a kind of saddle point. It looks like saddle. So like minimum here, but maximum there. So it's not simple. So in that sense, I think it's a good try, but it's not rigorous at all. The theory is totally a different from what you learned. But I don't know if you learned it carefully, how carefully it is, how carefully you learned it. But there is a new course, another course to show the uniqueness, how the minimization or maximization works in the Lagrangian setup. So it's not a good idea to use it without knowing the details of them. At least I wanted to, like, if you in like it was a take-home exam. So if you searched for more theory about Lagrangian, then answer could be better than this. Then what I expected was this. Just change the regression, rearrange the parameters from here, the structural form equation I call this, and then we call this reduced form. We rearrange the equation so that we can handle it easily. K, 1 times K, move to the left-hand side, and right-hand side has L minus K. Then you can redefine this as Y tilde and this as X tilde. This is the easiest way, simplest way, and the best way to estimate that. And now then you have to show the assumptions. And how can we do this? Because it does not violate any assumption, then why not, right? That's the point. You just need to check the resulting equation satisfies the assumptions. That's what you need. And then once you have this, it'll be super easy, right? From here, it's the easiest possible form of equation, like regression equation, and then criterion function, sample criterion function. Then automatically, after you calculate beta, you can rewrite this regression equation as this. Not a problem at all. So you observe y, l, k. So y minus k can be calculated. So everything can be calculated. And the reason why I'm writing here, still I find some students have no idea what is population, what's sample. So I use this notation as a population covariance, population variance. And furthermore, it is not well defined. In this case, x is vector. So notation is totally wrong. Defined x this way. X is 3 by 1 vector. Then variance should be 3 by 3 matrix. Covariance should be 3 by 1 vector. So at least it should be inverse, not so like covariance over variance. Totally wrong. And in here, in part B, I'm asking a population criterion function, but this is sample criterion function. Totally wrong. Sample criterion function, and this guy did not check the second order condition. Second order condition should be verified because that's important. Like in this proof, show that the true parameter uniquely minimizes the criterion function. The point is unique, right? Of course, like you have to show that it is a minimum, but the main point of this proof is uniqueness. That means the second order condition is the main point. So not showing the second order condition is never complete. So showing the first order condition is just like, then it may not be unique, and it may be a minimum or a maximum. So first order condition is not complete at all in this question. So that's another comment I wanted to give you. And otherwise, should be pretty simple. Still, some of you messed up. Okay, then I'm going to go to the last question in the next video.